Gentlemen, I want to say welcome. And before we get too carried away into the testing of this power supply, I wanted to cover a really good place to go buy them. Specifics are very important when it comes to these modules and what you can do with them. So let's go ahead, we'll jump over here to the screen grab. So first thing we want to do is we want to type into eBay dps-1200sb. That part number is, the SB portion of the part number is very, very specific. The very first one that comes up on your listing is the HP 1200 DSP-SB. This is the module we want to buy right here. So let's go ahead, we'll click on that. Now it says listing price is $22 or make an offer. Now what you guys are going to do, and by the way, the seller's name is Hoppin' Around. Hoppin-Around. You want to make an offer. So first you want to punch in the quantity that you want. Now I've messaged this guy. I bought a bunch of modules from him last night. I had one friend of mine buy some modules, and then I put it out in my Patreon group that this might be a possible good option for power supplies for everybody, with a short abbreviated version of this video that's coming up in Patreon last night. And as you can see, he sold 27 modules in the last day. And I'm sure that number is going to be dramatically more by the end of the day, by the time I get done being on the phone with a couple people here. You're going to come in here and you're going to click quantity, and you're going to type in the quantity that you want. It doesn't matter. He says 100 on site and 500 to 1,000 more in his warehouse of this specific part number. You're going to offer him $19 a piece. So $19 plus free shipping. Down in the terms and conditions, you're going to type in there, you're going to simply say BBI sent me. He'll accept your offer and you're done. That's it. These guys here, let's scroll down here, these guys here have the same unit. This is the same unit. It's for $1 more. The problem is that they took forever to get here. But this is a good, reliable company as well. You have to pay attention to the part numbers. They'll have the green label on them. Unless it says 1200 SB, don't buy it. The boards are different, and the information that's going to come from this video is not going to help you any. So, once again, eBay, part number, make sure you've got the right one highlighted. Then we're going to look for Hoppin' Around. Okay? Type in the quantity, make an offer, tell him $19, send him a message saying BBI sent me. He'll accept the offer, and you're off to the races and running. He literally has the ability to get thousands more if we need them. He has told me. He has claimed. Now, you know how sellers are on eBay. It's kind of like how people are in China. They'll do whatever it takes to make the sale. So we'll see. We'll see how well this goes. I have no personal connection with this person whatsoever. I'm not endorsing any of his past sales records. I don't know anything about him, other than we had a cute little conversation this morning when I bought 10 modules off of him. So, there you go. Let's hop back over to the camera now. Gentlemen, enjoy this video. It represents a lot of work. This is a couple days worth of tinkering and playing. I did get some help as far as a couple people told me where to go and what to start looking at. But I've really thoroughly tested this, and these units work. Hopefully this is a simple answer to a hard problem that we're facing in the radio industry right now, which is the lack of power supplies. The lack of power supplies is making building power supplies for consumers really hard. The Chinese market's got the whole thing messed up. They'll send us a pallet worth of parts that labeled one thing, and come to find out when we test them, they're a completely different thing. This is a different deal. Look at all the certifications that are on this power supply. It's compliant with everything underneath the face of the sun. So, all right. And that note, gentlemen, enjoy the show. Here we go. Okay, so tonight we're going to run a little test. I've been out here kind of dinking with this on and off. For a lot of years, These little HP supplies have been floating around. They've been very prevalent in the data mining industry. But we're having a hard time trying to find supplies right now, okay? These little 30 amp modules, just because they say they're whatever, they're falling on their face. Well, I first came out with that Amazon little tiny super slim little 30 amp module, and it did what it was supposed to do. The problem is the crowbar protection in it was too sensitive. So I had a friend of mine, I was telling him my woes of this problem, and I had a friend of mine, he pointed out to me, he goes, you know, BBI, and by the way, 249 is his name, is his numbers, Franklin. Super smart guy, way smarter than me. No problem admitting that, the guy's smart. He pointed out to me that they had bought some dps-1200s, him and a friend of his, and they got on the internet and they figured out how to make them so that they could come up in voltage. Now, for a lot of years, these little switch modules have been around forever. They are fixed at like 12.5 volts. And if you, the old posts that were out there about these switchers is you couldn't get them to go, you know, over 13.8, and they just trip out and they get really flaky and they're really sensitive when you turn them on. And the crowbar protection in them was way overkill. And well, that industry has grown up quite a bit. I mean, has grown up quite a bit. So he pointed out to me that there's been some changes. And so I went out and I did some research and I did a little bit of reading, and within about 4 or 5 Google searches, I was able to go in and figure out how to overclock these. It's relatively simple. You got to add 2 resistors. The magic shmoo is, I sat here and I spent probably an hour playing around with the different values of the resistors, and I was able to get it to 14.86 volts stable. Now I could play with this some more, and we'll get it towards at 15. So we're going to start out at 14.8. So these power supplies are rated for roughly 100 amps at 12.3 volts. We're past that now, okay? We're at 14.9 volts, 14.86, 14.9. We have to understand, for us to gain voltage, we are now losing current. And that sacrifice comes at a 20 amp loss. There have been people out there playing with these a lot longer than I have been. That is a fact, okay? Fact. So, what we figured out now by overclocking these just a hair is that this is roughly a 79 to 80 amp module. It's got a lot of built-in stuff to it. The other problem I always had with using these is that this little jet blower fan that's in here would run at full chooch all the time. So imagine if you turned on your power supply 24/7. You'd pull your short curlies out. By changing one resistor inside this unit, actually adding a resistor on 2 little solder pads that are on a board that runs down this side, it goes to a self-regulated unit. There's a thermistor or a thermometer or whatever that's in here that gauges the temperature of the unit, and the fan regulates itself via heat. So until the unit gets to about 115, 120 degrees, this is how much noise it makes. You could have 100 of these stacked together. That's how much noise they're going to make. If you pop the tin on it, the fan's just barely turning at this voltage. Now what we have set up over here that you guys can't see is my old beat down, set on fire 15 times in a row on video carbon pile. We're going to put probably a 40 amp load on this, and we're just going to let this thing marinate. And we're going to let it get hot, and we're going to find out where its cutoff point's at. So first, let's turn on the fan, which represents about a half an amp worth of load. So the carbon pile's got a fan going on it. That's what you hear. What we've got going on over here is our fluke clamp over gauge, and then our fluke voltmeter. Now at this price point, which is $15 to $20, it beats the shit out of these at 20 to 40 bucks. It's smaller, it's more compact, there's less shit to modify in it to get the voltage up on it, but the voltage is fixed. Now I could probably go in and figure out which variable, blah, 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 I got to change in it, and then run a lead wire out of here and make it a reference to ground through it, like a 50K pot or something. For today's experiment, just to see if this even works, here's our voltmeter, here's our amp gauge, we're fixed at this voltage. The outside emitting temperature, there's a little silicone plate that sits in here between the rectifier and the voltage control MOSFETs. The outside temperature of this thing is 95.7. All right. So let's go ahead and bring on a little bit of a load. You're going to find that this is a fairly stiff supply. So let's start bringing on some load. There's 6 amps. Come on, 6 amps. 13, 14, 15, 25. Now it's already outperforming the LED switch modules by a country bumpkin mile. The voltage sag is not present, and we're already putting more amp load on this. Now, the other question I know I'm going to get asked a lot is how sensitive is the on-load crowbar protection? We're going to unplug it, off, plug it back in, on. That's under load, 40 amp, turned on with a 40 amp load attached. Pretty stout. So now we're just going to let this cook. As the carbon pile goes up in temperature, the plates are going to expand and the amp draw is going to go up. When we get around 80, we're going to notice our voltage is going to start to sag. And once the voltage sags a little bit too much, about a volt, this thing will shut off automatically. And if at any point we get this power supply too hot, it's also in turn going to shut itself off. Now it's going to try and protect itself by the fans going to start kicking up. It's got 2 gears to it. It's a little float standby right now, what we've got going on. We're up to 110, 111. So we've come up 15 degrees. Oh, load pile backed off. Let's give it a little tweak. Keep coming. Here we go. It'll kick into another stage. The fan's going to go wee, 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 and then it's going to shut off because it's trying to cool itself and it can't. So it's protecting itself from burning down. Right now, at this price point, at $15, and about 5 minutes worth of modifications on the inside. Now that I know what to do, it's literally 5 minutes. So undo these 4 screws, add 1 resistor, add another resistor, and then adjust a potentiometer. We're at 14.6 volts and still climbing. So let's go on up here. Let's get up to about 65, 70 amps. There we go. So now we're pulling 60, almost 70, there's 70 amps, 71 amps. We're still at 14.6, which is great. Let's back the pile down just a hair. Let it keep climbing. The idea is to let this float up to about 80 and then kind of keep it around 70 to 80 amps. We're trying to get the unit hot. There's the fan. So now let's back our load down. Back it down to about 50 amps. And we'll see how long this can run before it goes into shut-off mode. That's what it used to sound like all the time. You got to remember, us radio operators, we're not putting a constant load on the supply like this. We're at 120 degrees Fahrenheit. And we're gaining ground in the temperature department. We're starting to lose temperature out of the power supply at a 50 amp load. So we'll say conservatively, that this power supply is rated for 50 amps, continuous, 80 amp surge, right? Because with the fan running at full chooch, with around a 50 to 60 amp load, and we're not at crazy super fast mode, so you're still dropping in temp. There's a whole nother gear we can take this to. Let's go ahead, we'll bring that load back on up some more. We'll float it up around 70. $14.6, 79.9 amps, 14.6. Let's take a quick temp reading. $101. We're at our 80 amp draw. Now watch, our volt's going to start to just fall off. See that? 80 is the max amps draw that we can keep on the power supply and keep it at 14.6. So let's back this off. We'll go to 67 amps. So now, just pull the load completely off the pile. Oh, and it just went into crowbar overheat protection. Let's go ahead, we'll reset the power supply by simply unplugging it or flipping the on-off switch on and off. Plug the power supply back in. 14.8. So now we'll pull all the load completely out of the pile. And now we're going to let the pile cool down because the pile's now at a couple hundred degrees. Our carbon pile. And I'll let this come back down. So we're already down to 92. So let's go ahead and raw dog it, or put a significant current load on the device and crowbar. What did I tell you? This pile is old. The plates aren't smooth and linear no more. Let's unplug. And plug back in. Okay. Let's see if we can slowly work the pile back into play here. Maybe it's still too hot. Maybe internally we got it too hot. Oh yeah. Let's let it cool down. Let me get the temperature of this thing back to normal, and we'll try this again. Okay, so I got this working the way I want it to now, and I'm happy. So let me cover some notes, because I know other builders out there and other people on the internet are going to want to know how to do this. So for specific reasons, this is the DSP or dps-1200sb. Relatively cheap model little power supply made by HP. For us to get our voltage that we want, we have to adjust a couple things and change. We have to add 2 resistors. Now I stole this from, I won't say stole this, but I found an article that was on Reddit that was about this power supply and how the one particular person went and modified the supply so he could get away from the 12 volts. When you get this thing out of the box and you put 110 volts to it and you apply the jumper to it that makes it turn on when the voltage shows up at the power plug in the front over here, this plug, his goal was to achieve 13 volts. You can't really get there. You can get to like 12.8. This is your potentiometer that adjusts your voltage. This is the potentiometer that adjusts the crowbar protection. And let me zoom out so you can have a field of reference. This is your positive rail. If the power supply was laying flat and the plug was on the far left-hand corner or farther away from us, this side, okay? Now, what he suggested to be able to get to 13 volts, which kind of unlocked all of this for me, was that we put a 15K resistor here. From this pad to this leg on the variable. Now please note how I have the variables adjusted. This one is turned all the way to the left, and this one's right down the middle. So at 15K, we end up getting 14.2 volts, and that's with this knob maxed all the way out. Now I went on to play with it because I'm sorry 14 volts wasn't enough. So then I went and I dropped the 15K to a 12K, and that got me to 14.9. So 14.9 max volts here, adjusting here max volts. What we're adding here is a 12K resistor. Well, that still wasn't enough for me. There's two parts to this equation. I'm just going to cover it in its sequential order. This is a 9K resistor that's in here now. I have no problem with people copying me. The only thing I ask is that you give me credit. I learned how to do this by watching so-and-so's video. The gentleman on Reddit, I went to go give him credit and message him, and he's no longer even active, so it's not worth giving credit to him. And remember, what inspired all of this is my friend Mr. Frank, Mr. 249, the man, the myth, the legend. Very, very, very smart commercial engineer. Okay? He said that this was possible. Like I said in the beginning segment of this, I fiddly farted around with these, and I could never get them to go past about 13.9, 14 volts without the crowbar protection kicking in. The crowbar protection is the hardest thing to fool in this power supply. Very, very sensitive. Like it would, like you guys seen in the last segment, where I'm sitting there and I'm moving the load on and off of it, and it would just clip out. Well, today I came out and I said, okay, enough of the carbon pile. Let's actually hook a 2-pill up to it. I could not run a 2-pill on this without it going into crowbar protection. I couldn't. It was too damn picky. Now on the back side of this thing, let's flip this over. Let's see if I can get all this in frame for everybody. On the back side of this thing, I had to add a little tiny resistor down here to help with the crowbar protection. Focus. There we go. This resistor here attaches to the same pad as this resistor. So you can count them off with me. 1, 2, 3, 4, 5. The fifth pad from the center. So 1, 2, 3, 4, 5. You solder one leg of the resistor to this pad. Then down in here is a little 4-legged IC chip. A little black square chip. You guys see that? You're going to tie the other end of this leg of this resistor to this 4-legged chip. You're going to put it in the second leg from the right. As you go up in voltage, you have to adjust your resistance down. If you try to just go ahead and put the resistor in here, which I've currently got at one of the lower voltages, it screws up your crowbar protection over here on this variable. Let's see. This variable here, right there. So you have to do this in steps. So like I was saying, if you want to achieve around 14 volts, you're going to put a 15K here, and then you want to put a 51K here. Okay, so to achieve 14.9, you're going to put a 12K here and a 39K here. Now what I ended up doing is I ended up going to a 9K here and an 18K here. So if you think about it, 51 to 18K. I've tried it every other way. Every other resistor combo from 51, I think in the notes the guy actually said 58. From 51, and had to slowly walk it down, and 18K is where I ended up. That's what I did. Now let's cover the technical specifications of this unit one more time. Then I'm going to button it up and we're going to go on and we're going to go play with it. And I'm going to show that this thing actually works. Because I've been tricked before where it's like, oh yeah, oh I've got this all figured out. This power supply is awesome. And then I go and I put it in something and it doesn't work so hot. Crowbar protection takes over. It doesn't like having RF attached to the end of it. Got to add 55 isolation shunt diodes to this, that, or the other thing. I think I have all that beat, but we don't know until we test it. Now it says here that we have two sections of input. 110 volt through 120 volt pulls 9 amps. All right. Well, that's on 110, but if we just let our eyes slide over here, 200 to 240, now we're pulling 6 amps. But here's the neat bit. Output, 900 watts, 220 volts, 1200 watts. 12 volts, 75 amps. Now remember, underneath our testing, we were able to get it to run stably at that higher voltage at an 80 amp load. I thought we had her cracked. Then we hooked it up to a real amplifier. Guess what? Found out it wasn't happy, so we had to come in and play with the crowbar adjustment again. To get the full 100 amps out of this, we've got to be on 220 volts, which makes perfect sense. Everybody see what I'm talking about? Okay. Once again, dps-1200sb. I'm in love with this little switcher, and I'm going to show you why here in a second. Let me get this all buttoned up. And as far as that 1K ohm resistor, 1000 ohm resistor that goes from pad 1 and pad 4, forget all that. Just jumper the pins together. Pins 1 and pin 4, just jumper them together. And the thing will turn on as soon as it's got 110 volts or 220 volts applied to it. All right, let me put this all back together. And the only other modification that I want to do, and I'm going to do it post this testing, by the way, is this is our temperature gauge. This is our input air temperature gauge. I want to move it. I'm going to move it closer to over here, where most of the rectification cycle and most of our heat comes from. It's really important that we leave this little plastic cover shield on here, because there's a silicone heat transfer pad that's right here, and it sits right over the top of this piece of metal and allows heat to get transferred to the case, because the case is also acting as part of the heat sink. So let me get this buttoned up. Let's start to play with it. Okay, so our resting voltage right now is 15.89. The reason we can't go any higher than 16 volts is because of the output filtering capacitors that are here on the back end of the power supply. 15.89, when you see this thing run, you're going to be like, okay. Now, another problem that we've had that has presented itself, and it's something that I have to go and look for every single time I go and I start talking about power supplies, is their noise to other devices. What kind of noise does sharing the common ground with this switcher is it going to introduce into, let's say, somebody's receive in their radio? Some power supplies have a tendency to inject noise in the lower HF frequencies. So let's start out up here for right now, and let's take a look for here. Our preamp is off, so we're going to add to the second stage of preamp. Now the power supply is on. That's case to coax connector. What do you mean by case to coax connector, BBI? This is a very crude test, by the way, so don't get too awfully upset with me. This case is grounded. This is the coax connector for my ICOM 7300. There's no noise. I mean, that's literally tipped to the case. Not shorted out, that's just tipped to case. No noise. but we're up on 10 meters. No noise. So let's go ahead and let's go down. Now, I don't know what this is going to do. I honestly don't know. So there's a little bit of noise all by itself. Case. Now tip to case. Case. Now, let's shut the power supply off. Noise is still present. Okay. It's so minuscule though. That's just the environment that we're working in. And to get that noise, I'm doing this. If I was to do the same test with this here, we'd have 50, 60 plus dBs of switcher noise. So a little bit cleaner design. This is a very crude test. I could hook up the spectrum analyzer and do a fan antenna array and put it in a RF anechoic chamber, or a Faraday cage, and measure it all that way. Or I could just simply max out the receive on my fancy dancy ICOM and say, hey, what do we got going on for receive issues? Nothing. So let's shut that off. Okay. Now for the big test. Let's get the power supply plugged back in. Bloop. 15.87. Let's get our amp ring hooked up and let's start playing with it. Okay, I think I got all the tools in play that I need to do this test for you guys. This is an 80 amp supply. So in theory, I say, we should be very careful here because we are at the max end of what this supply can handle. And you know what? Here, let's do this. Let me go down here. We're going to unplug it from the workbench supply and we're going to go to a committed 30 amp 110 outlet. Okay. I don't need to mess around with that anymore. Let's do a baseline measurement. Power supply at idle is producing 78 degrees of temperature. Everybody can see that. 78. 15.89. Over here we have our amp gauge floating 1/10 of an amp, or 1/10. So we'll go ahead and we'll apply our fan and our LED. So we're seeing 3/10 of an amp worth of a load to the supply. Now what are we going to drive the 4-pill with? Well, of course, the derail striker. So let's go ahead and let's look at our watt meter. This is a 1,000 watt slug and peak, 1,000 and average, 5 watt slug and reverse back from the bird, 10,000 watt dummy load. Let's go take a look at this. Making our 120 watts worth of drive. All right, everybody knows what's going on now. We've set all of our baselines. So let's go to playing. About 400 bird in the corner from a 200 watt, 180 watt, 190 watt carrier. 1, 2. Now our amp draw is not all that impressive to me. What is impressive is the size of this little supply and the simple fact that I can hammer it with a 4-pill and it not go in a crowbar. RMS meter, peak meter. Technically we're pulling outside of the power supply specs. But look at our voltage sag. 1, 2. All right. The crowbarring effect was the hardest thing to overcome. Just kept dropping the resistor down as I was bringing the voltage up. Remember, the two things work in tandem. The lower the voltage you want the... Okay, covered that. 87 degrees. Now let's have a little bit of fun with it. I've been caught before where I came out and I'm like, oh, this power supply is awesome. Then we actually go to use it. We find out as soon as we try to use it on sideband, the thing goes, "Ah," and it freaks out. So now we're going to go over to sideband. We're going to be on lower side. Hello, 1, 2, 1, 2, 1, 2. I don't want to do the sideband test too long because this does not have bias in it. The reason we're doing it is I want you to see the amp load here versus the power being produced plus the average number. So let's start looking here, then we're going to look here, then we'll look at our numbers here. Hello, 70 amps here. Hello, pretty freaking stout in my opinion. Look at our numbers over here. Hello, okay, enough murdering my Toshiba-based 4-pill bass or workbench amplifier. Oh, under that old Model T was a place she first showed it to me. It was big and black and she called it a crack, but it looked like a manhole to me. So I pulled out my old power pole and I stuck it in her black manhole. As she began to scream, I poured on that cream in the color of the old Model T. Ding, 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 ding. Hello, 1, 2, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Now I'll pretend I'm a ham operator. Well, good morning, Fred. Bob over here. I got up this morning and, man, my big toe, you know, I can't get down there and cut that toenail no more. Man, I got caught up on a bed sheet this morning. I sliced the whole bed sheet in half. Man, once you know it, when I bent over there to get that bed sheet and pull it up off my big toe with a snaggled tooth toenail on it, man, I farted. But I farted a little bit more than what I thought I should fart. Man, then you know Martha had to come up in here and help me get up out of bed this morning because by the time I said and knew it was all done and over with, man, my snaggled tooth had catch the bed and I fell on my ass. Next thing you know, I had a little bit of brown up in my eye. I might get pink eye out of this thing. I don't know what to do, Fred. I just don't know what to do. Bob over here, back to the rest of the group. That's a fairly decent long key down. We're at 112, 113 degrees on the outside of the cabinet. We're in a 70-degree environment now. I mean, to me, I'm cool with this. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Making 450 watts on the bird scale, whatever that counts for, because I have a hard time, a mental block using this as a reference of measurement anymore. Now that I understand that these meters were never designed to be used on AM. That's the reason Bird had to develop the peak kit. Believe it or not, get that beat into your head because it's a fact. These meters are designed to read sideband, FM, or CW mode. They're not designed for AM. That's the reason Bird developed a Bird peak kit. Anyhow, an unpeaked Bird meter, that's what it reads, about 425. Hello, 1, 2. We're cresting up to at about 1,000 watts with 120 watts of drive running just this. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. At $20, $25 a piece for these units versus 3 $25 or $35 or $40 a piece modules. These create a ton of noise and will totally screw up your receive. No noise and a third the cost, and will actually work. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, come in. In fact, I can put it on sideband with no fear. Hello, 1, 2, 1, 2. No crowbar. Now it's still got crowbar protection. If you short out the positive and negative leads, this thing's going to shut itself off. You get it too hot, the thing's going to shut itself off. I'm going to keep keying it because I want to get faith in this thing. Oh, about 40 minutes later here, guys. We're up to 125 on the case temp. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, audio, 1, 2, 1, 2. What's my exhaust air temperature on the box? 102. Hello, 1 2 1 2 1 2 audio, 1 2 1 2 1 2 1 2. And remember, we're on the 110 volt side. Now, this is what we call an auto sense, auto switch power supply. So you just dump 220 on this, standard color code applies, and it automatically switches to the 220 side. 220 side pulls less current, and it makes more amps. This is where we get our 100 amp. 100 amp. I mean, 60 on the sideband side, I've seen 80, 75 to 80, and this sitting at 15.6. That's a little high for most people. They're not going to want to run their components here. The reason, like their radios, they're not going to want to run their radios. They're not going to want to. The reason I got the voltage cranked that high, one, is to build confidence in the system myself, because we all know, once you go higher in voltage, you're going to sacrifice a little bit in amperage. I mean, really, the butter zone for this supply, in my opinion, is where we do the 12K resistor here, and we do the 39K on the crowbar protection. That's, 14.8 or 14.5 to like 14.9. Solid, like a rock, like a rock. And if you end up having problems with it going into crowbar, I mean, it's okay to go ahead and start playing with that crowbar resistor and maybe take the crowbar resistor and drop it down to 21K. So food for thought. Now there's one other question that we have left yet to answer. Are they stackable? And do they interfere with each other when they're stackable? Because in theory, if I stack that up and put them on 220, that's a 200 amp power supply. Regulated, fixed, controlled, smooth. The downside to this, so far, as far as I can tell, and I'm sure if I spent more time totally farting around with the insides of this thing, I could figure it out, is that if we try to do an external voltage control for these units, the crowbar protection is set up thus that if we slaved like 4 or 5 of these together, tied 4 or 5 of these together, exactly what's going to happen with the crowbar protection is we vary the voltage up and down, let's say from 12 to, let's say, 15. Haven't gotten to test that yet. But for the average novice guy that all he wants to do is undo 4 screws and add 2 resistors, this is like a wet dream. You do not have to use big high watt resistors. This is what I used. It was a little tiny Peter Dahl or Dahl resistor, like a 1/4 of a watt. Doesn't have to be anything substantial, and you really don't want it to be because you're trying to fit it into a tight space. This fan is turning, it's cooling the power supply. Power supply gets too hot, this thing goes into crackhead mode, as we've all seen. I got a bunch more of these coming after today. I sat down and spent $500-600 on these modules after today, and I have been hunting for a whole bunch of switchers that are in the market, and they're everywhere. You can go onto eBay, $25, $20, and have them coming. Please take note that there are multiple different versions of each power supply, like this one here. Exact same footprint. Exact same footprint. Same size, same dimensions, but this is a 460 watt supply, which works out to be about 40 amps. And guess what? Same price. Why have a 35 amp supply when you can have a 100 amp supply? For the same price, same footprint. These do have, or they don't have, there is no mounting for this, like physical screw mounts. That is a drawback from these guys that are all covered up with mounting holes all over the damn place. So these are designed to go into a server rack, click them in and lock them in. They plug into a rack system. So there's going to be some dudes out there that are going to do some beautiful work with these supplies, I have a feeling, myself included. How they go about terminating. They do make breakout pads for these, so you can plug them into a breakout slot. Just food for thought, y'all. Just putting this knowledge into the digital ether. Food for thought. I also want to make this very clear. I did not figure this out on my own. I had help. And as far as I know, there's one other builder in the world right now, my friend over at Hopper, Mr. Nate. He's starting to work with these as well. I have not spoke with Nate. I just simply know that as of 2 days ago, he was talking about working with these himself, this style. They make this exact same model, but with a different last 2 digits. Instead of being SB, it's like FB. The FB, there's a whole bunch more knowledge about it. Of course, they're a little bit more money. They're like $3 or $4 more. But they are, instead of a 1,000 watt, they're like a 1,200 watt version. Not played with those yet. I'm just playing with these. This is where I'm starting. So I just thought I'd put the food out there. And hopefully somebody's going to be able to take and use this and build themselves something fun. Or they're going to be able to, whatever. Just saying. If you use what you learned here, give credit where credit is due. If you come up with something else, please don't be ashamed to come share it with everybody. Because once again, I'm not saying that I figured this out on my own. I did not. And I'm not saying I'm the only one in the universe that's done it, because I am not. But when you go do a Google search for this particular supply and how to modify its voltage and voltage hack, voltage mods, there's slim to no information, or they go off and they start talking about the FB or the FS version of this power supply. So, on that note, I'm going to say, gentlemen, thanks. Appreciate everybody watching, following along. Hopefully somebody can take something fun out of this and away from this and learn from this. Big shout out to Penna, Excess Power, Siglet, McMahon, Bird, Coaxial Dynamics, every single one of the YouTube viewers, every single one of my Patreon supporters. The Patreon support means more than any of you guys will ever understand. YouTube does not pay worth a damn. These videos don't even generate enough money at the end of the month to pay to turn the lights on around here. They don't. The Patreon supporters are my lifeblood. They have been there with me now for almost a year. I try to dump all content on there that I create over here. There's a lot of stuff that I do just for them. And the reason I do that is because they've been with me for the thick and the thin, right? My highest and my lowest points, they help lift me up and they help keep pushing me forward. I put stuff out there and they're like, BBI, you just go do you. We love what you're doing. If you want to be part of that team, come join us. Type this into Google and you're going to come right to us. Big thanks to all of them guys. And on that note, here comes the list. Gentlemen, please let me know if I can help you in any way. I do have a bunch of other notes that I've created while working on this thing. If you have a problem or a question, call me. I will do the best that I can to give the information that I've created out of my own brain, which is not much, but I'm always willing to share, as you guys know. Gentlemen, I'll see you. Click, click.